Hello everyone, this is Tech Remedy. Thank you for tuning in. Today we will discuss the difference between variable types, their ideal use, how to choose your variable, and how to properly declare them in your program. Stay tuned. Before we start, please do not forget to like and share our video, and of course subscribe to our channel and activate the notification bell to receive all our videos and be notified when new tutorials are posted. Also comment down below for any feedback or suggestions. We sincerely take every comment seriously and plan our future videos based on your requests. If you are using a web browser and somehow familiar with what we are doing, please remember that you can always speed up the video and save time. Let's jump to our topic for today. Variables are storage areas with changeable values. We give that storage a name and a type, and voila, we have a variable. To declare a variable, first you need to choose where to declare your variable and then write dim followed by a variable name and then write as and then your variable type. For example, if we write dim techremedy as integer, here we have declared a variable called techremedy and its type is integer of 32-bit. Variables are divided into three main categories: integers, floats, and others. Integers, the first category, contains byte, short, integer, and long, and of course their siblings. The reason why I said siblings is because each of those has the exact same range as its sibling. Let's take byte for instance. The size of byte is 8 bits. That gives us a range of 256. which is the range of byte from 0 to 255, and also the range of S byte from -128 to 127, meaning that one of them spreads its range over the positive values only, and the other one spreads it half positive and half negative. So if we draw a line from -256 to positive 255, byte will take the range from 0 to 255, while S byte will have the exact same range but spreading from -128 to 127. And of course the same story applies for each of the subgroups. The famous one here is integer. Let's just keep that in mind. Float, on the other hand, contains three types only: single, double, and decimal. Single can take up to 7 digits as decimal places, while double gives almost the double, as the name might apply, with 15 decimal places. Decimal is the most precise with 28 digits after decimal point. So if you are someone who really must work on accurate figures and do not care that much about the area or size your application is going to take from your disk, then decimal is your choice. If no requirements are applicable, then you might go with double. The last category has 5 types, and they are char or char for single characters, boolean for true or false, yes or no, on or off, call it whatever you like, object to declare objects, which is platform dependent, date to declare a variable that can contain date and time, and finally string to declare strings or set of words, sentences, etc. It can even contain numbers, but they will be treated as letters or strings and not numbers, not taking conversion into account, of course, which we will cover shortly. From the table you can see the size and range of each variable type. The only thing that is worth mentioning here is that string has a changing size depending on the stored values. For instance, if we take a variable and store techremedy as a string in it, then its size will be as per the given equation: 80 plus 16 times the length of the variable, which is 11. That would give us 256 bits or 32 bytes. As we said earlier, the way to declare a variable is to write dim variable name as variable type, right? So if we add equals to and then give it a value, that would be the initial value for our variable. Also, we can declare more than one variable in one sentence or line, either from the same type or from different types, given the condition that this declaration method does not allow us to give initial values for our variables. All those variables are called local variables, and that depend on the way we declare them. If you remember, we said to declare a variable, we need to choose where to declare it and then write the code. Well, that place is the local place for the variable, and that given variable can be used within that place or location and all sublocations, but cannot be used in any parent location or location with a higher level or a different level. So let's jump to Visual Studio, open our Visual Basic.NET application and try declaring some variables. Here's the last project we were working on. I'll just create a new form, call it frm variables, and then try to draw some user interface to help us work with the variables and see their types and their outputs. I'll speed up the video from here, make a small design for our user interface, and then I'll catch up with you guys. So here we have our user interface ready. I've just given a name to each and every controller or component we have on our user interface. As you can see from the list here, they're all renamed. The idea is to take the input from this text box, set it to this variable type over here, and then give the output to the other side. So this is called txt input value, and this is called txt output value. So we'll just go to byte. First of all, declare a new variable, dim our variable as byte. Then our variable will have the value of txt input value dot text, and then give that output to our output value, txt output value dot text equals to our variable. Let's run our program. Of course, we have to change the initial running form. We'll go directly to project, properties, startup form, put it variables, and to save time, we can remove the splash screen for now. We go to our variables, close all other opened objects, save our project, make our form run in the center of the screen. Let's run our program. Let's write 25 for example, write type on byte, so that's our output. Its type is byte and the output is 25 as well. If you write 25.2 for example, that would also give us 25, just because all of those types of variables are integers and they do not take any decimal points, but they round up the numbers. So if we write 25.9, that would give us 26. Bytes, as you remember, takes only positive values from 0 to 255. Any number outside this range will cause us an overflow error. So if we write minus 25.9 and hit on byte, that would cause us an overflow error. To overcome this problem, we need to put a handler for the error. We'll come to that one in future videos. I'll just type it quickly here. Try this, or give us a message box that shows the error we're facing. We can put the type to critical. 25 works fine. Minus 25 gives us an error. Let's do the same for the other buttons of integers. I'll speed up the video and I'll catch up with you after I'm done. So I'm done with the coding. Let's run our program. Write minus 25.9, hit S byte. You see that it's rounded up to, or rounded down in this case, to minus 26 with the negative value. Click on byte. That would cause us an error. Oh, we cannot see it here because the value written here is due to the last action we did with S byte. Let's just correct that one as well. txt output value dot text equals to error. Let that one, paste it with each of the exceptions. Run our program once again. Type -25.9. You see that bytes throw us the error and writes error over here. S byte gives us -26. Short gives us -26 because short can take negative values, U short cannot take. Those are the up variables, so U short, U integer, and U long are all positive. Byte is positive, S byte is negative, so U short will throw us the same overflow error, U integer will throw us overflow error, and U long will throw us overflow error, while the others would work fine. If you remember, byte can take up to 255, so if we write, let's say 260, byte and S byte will not take that one and throw us overflow error because it's outside the range of those two variables. But that would not be the case with the others because their range is too high. So if we write, for example, very long number, short will throw us an error, integer will throw us an error, and long will throw us an error because no number can handle that long. No variable type, sorry, can handle that long. Let's take it down. Still too much. So those can take it, integer cannot. U long can take that value, long cannot, because U long put all its range in the positive value, and that gives us a higher number that can be stored here, while long cannot because it's too large or too small for integer 64 or a 64-bit integer type, which is long, and in our case it's too large. So let's do the same for single, double, and decimal. I'll just copy the same code we wrote, change this one to single, put it in double, change it to double, and put it in decimal, and of course change it to decimal value. Save our program, run it, and then let's write 1500.250. You see that single take that value, double take it as well, decimal take it as well. Let's write even a longer number. Let's copy this over there, hit single. We can see that single takes up to 8 digits, double takes up to 15, and decimal takes up to 28. So as you can see here, single gives us the same value actually, but it's not as precise as decimal, while double comes up in between. So depending on the degree of precision you're looking for, you can choose the floating points or the float variable type you want to work with in your project. Let's try to do something for the others type. They do not really apply for values because they're not values, but let's try it and see. So for char, let's just copy the same code we wrote, make it char boolean. I'll skip object, date, and string. Let's run a program and see what we face over here. 123.456. Char would give us 1 because it takes only the first character. Boolean would give us true because the value is higher than 0. If you write 0, that would give us false. If you write a negative value, that would give us true. So anything other than 0 in Boolean is true. Let's write our number once again. If we change it to date, it tells us that this is not a date, so it gives us an error. And string gives us the exact same thing written over here without looking at its value. So if we write even hello world, that would be written over here, and this is treated as letters and characters and not values. So let's try to do something with the date. It cannot be written like that. Let's write 8/8/2020 that is changed to date. You see that, but 08/08/2020. Even if you write it like that, that would be the same value. Just write it like that, that will still give us the same value, while string gives us the exact same thing we wrote over here in the input box. So as we mentioned earlier, those variables are called local variables, and the reason why they are called local variables is that they can only be used within the area they were declared in, and that's the reason why we can use the same variable name in all of those places. If it was declared outside those private subs, then we would not be able to declare the same variable name with different types. So let's try to do something to show the local variable properties. Let's declare take remedy as integer, give it an initial value of 25, for example. Here we have a local variable called take remedy. Its type is integer and its initial value is 25. This variable is valid and it exists in our program, but it exists only inside the private sub of this function, button byte click. So if we try to use the variable in this area, let's say take remedy equals to 26, for example, it would tell us that take remedy is not a valid variable and it's not declared. The reason for this error is because this variable is declared inside this private sub function, and it can only be used in this sub function. So if we take this one out, declare it in this area here, you can see the error is gone, and now I can rename that variable, and you can see once I click in it, it highlights the same variable all over my program and highlighted the variable that was declared in. If we take this one from here, cut and paste it inside this one, you see that this one changed to error because the variable is not declared. And if I click at this one, it would not highlight this variable for me. If I click at this one, it will not highlight this variable for me. That means they are not the same. So let's take this one up. The error is gone. If we go back to our main form, if you remember in our previous episode we had this form we were working on. Let's give the button an order to show me the variable value of take remedy. So if we say take remedy equals to 27, for example, it would also tell us that this variable is not declared just because it was declared in this form only and cannot be used in any other form, because it is within, this variable is within the class of form variables and it can only be used within variables form and not any other place. So that was the reason why we called it local variables. Now to declare a global variable, we need to create a public module and then declare our variables inside that public module with the keyword public instead of dim. So we create our module, and inside that module we write public and then the variable name and then as and then variable type as we used to do. So let's jump back to our program, go to our project, right click on our project, add, and then we choose module. Let's call it module global variables. Hit OK, and then inside that global variables module we will write public take remedy global as integer. If we go back to our variables form, remove this one, then go to this one, make it take remedy global. You can see that we can access it from here, we can access it from here, we can access it from here, we can even access it from this form. See, that tells us this field is a global variable from the module global variables and its type is integer. So that's how we declare our global variable. Another subject that I wanted to discuss with you guys is the conversion between variable types. So if we have a variable of the type decimal and that variable has a value, a certain value, we can change that value to another type while handling it. So let's go back to our variables form, enlarge it a little bit, create a button, I'll make the example to one variable type only, change it to integer, and the same thing would apply for all the other variable types. So let's go back to this button. Sorry, we forgot to rename it. Let's go back to our form, rename this button convert to integer. Double click at our button, we'll have the private subfunction. We'll take the output dim converted variable as integer, converted variable will be equal to c integer, that means convert to integer. You can see that you can write it cu int as well, that would convert it to u integer, and all the other variables would apply in the same manner. So cint txt output value dot text, and then we'll throw that result back to output value. So txt output value dot text equals to converted variable. Let's run our program. Let's write 123.456. You can see that decimal would accept that number because it accepts numbers with decimal points. So let's convert it to integer, and that number is directly converted to integer. If we click on decimal back again, that would show us the numbers. If we make it 123.987, decimal would show it, integer would round up the number to 124. All the other variables would apply same manner. We can convert any variable type to any other variable type if the conversion between them is applicable, like from byte to short, from short to integer, integers and floats among them, and so on. You can always convert any variable to string. You can convert any string to a variable with a value if you are sure that the value of the string is numbers and not characters. There is another way to overcome the error of having text in your variable. For example, let's say hello world. You can see that the string would accept it, while integer would throw us an error that hello world is not an integer type. So to overcome that problem, there is a function called value, or val. That means throwing the value of this input only. So it would take the mathematical value of this variable and then convert it to integer. So if we go back and write 123.45, that would work the same. Converted to integer, it would be rounded down to 123. If we write hello in decimal, that's an error. In string, it's not an error just because this is a string and it's converted to a string, which is the same. If we convert it to integer, you see it gives us 0 and not error, or it would not throw us any error from the program regarding the variable type, just because we took the mathematical value of hello, which is 0, does not contain any number, this is 0, and then converted that 0 to integer, which is still 0, and showed us the result. So that's also a very useful function. You will be using it a lot in your programs. Well guys, that was all for this video. Let me know in the comments down below if there is any other way you use to declare your variables, or if there is any other method you follow to handle your inputs and outputs. Please do not forget to like this video, share it with your friends, and of course subscribe to our channel to keep receiving more videos and tutorials. That was a Tech Remedy. Thank you for tuning in. I'll catch up with you in the next video. See ya.